Okay, so we are in 3.1. It's a new unit, and we're talking about polynomial functions. Okay, so you learned about polynomials back in integrated 2 when you multiplied them, you factored them, and you're going to see a lot of that here. And this is actually one of my like favorite or chapters of what we're learning in integrated 3. So let's just get started. So what you will be able to do is model patterns of growth with tables, equations, graphs, and diagrams. This is really important. Ms. Johnson loves tables. I love graphs because it helps me understand what an equation looks like and what it's doing, right? And diagrams. Okay, so make conjectures about function rates of change. A rate of change is like how much it's growing up by. And if you look at this very first pattern, you can see that. And then connect that understanding to functions that we've already studied. So your job for this unit is to be able to look at this picture and describe it using tables, equations, graphs, words, diagrams. The more you can describe it using all of those things, the easier this unit will be. I don't like using the word easier. The more understanding you will gain from doing this. Okay, so if you only know tables, that you're like limiting your understanding. Okay, so we skipped the jumpstart problem, which talks about like his the number of push-ups, I think. Yeah, the number of push-ups that he did. Okay, and then we're moving on to this part here. So a big promotion at the gym last year required Scott to keep track of the total number of push-ups he had done in March. The March motivation promotion raised money for charity by finding sponsors to donate based on the number of push-ups completed. So like, who cares? Keep listening. So Scott used the diagram and the table below to show the number of push-ups he did each day and the total number of push-ups he did in the month. So again, this is the number of push-ups he did each day, day 1, day 2, day 3, day 4. And then they have a total, like a running total of how much he had for the whole month. Okay. He completed 3 push-ups on day 1, 5 push-ups for a combined 8 push-ups. And then he continues. So here's your pattern. Here's your table. So here's what they first want you to do. They want you to write a recursive and explicit function for G of n of the accumulated total number of push-ups Scott completed by any given day during the month. March motivation promotion last year. So they want a recursive and explicit function for this. So if you are like, Ms. Johnson, I don't remember recursive and explicit function, no problem. I'll put a couple of recursive and explicit function videos in our queue so that you can watch those and be like, oh, I understand what she means by recursive and explicit. So what do you want us to do here? So we're just looking for this guy here. Okay, so the very first thing that I'm going to do is I'm going to look for a pattern. So look with me for a pattern. My brain says, hey, are you geometric? Are you arithmetic? What are you? And so if you notice the total number of push-ups, and I'm going to do this really quick, and I know I only have a couple minutes, so be patient. So the very first thing that I'm going to do, and this is why I like my table so much, is I am going to figure out how the pattern is growing. So here I notice, oh, it's going up by 5. And then here, nope, it didn't go up by 5. This is going up by 7. And then by 9. And then by 11. And then on so on. So if this number right here, if it's at 5, 5, 5, 5, 5, 5, then this would be an arithmetic sequence because I have a constant difference. Yeah, no, we'll see that in a little bit. Okay, so as soon as this catches up to me, which it's not, just be patient. There it goes. So then because these numbers aren't all the same, I know it's not linear. So I'll write myself a little note here. Because the first set of differences, I don't know how to spell differences, are not the same. This is not a linear function. Okay, so I'll change that in a second, just so that you guys can, it stands out a little bit more in your notes. But so it's not the same. It's not the same. So if it was the same, then I'd be like, oh, I'm done. Then it's just y equals mx plus b. Okay, so this pertains to this. Okay, because they're not the same. So you're like, okay, so now what do we do, Miss Johnson? So the next thing I'm going to do is I'm going to take another set of differences. Yeah, that does mean something. Very good. Okay, so here I'm going to take this set of differences right here, and I'm going to go, oh, wait, look, this is a pattern, Miss Johnson. Is this helpful? Because this is 2. Yes, this is really helpful. And because my second set, so I'm going to copy this again. I'm going to copy this whole thing, actually. So I'm going to put this here. And so because the second, do you guys all understand what I mean by second set of differences? You all see what I mean by that second set of differences? I took the first set here, boom, 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 and I'm like, ugh, it's not the same. And then I took my second set and they are the same because the second set of differences are the same. This is a quadratic. Okay, and that makes sense because think about it, it has the power of 2, not because this is a 2, because it's the second set of differences, 1, 2. Okay, 1, 2. And so because that is that, some people are like, Miss Johnson, I hate recursive functions. Recursive for this one is actually really easy. Okay, so what would happen? How would I get the next number? How many would he do on day 6? What would I put for day 6? How many would go right here? What number would go right here? Yeah. So I would add, exactly. So here I would add 2 more. And then here I would add 13, right? So then here it's going to be 48. So here, this number here is going to be 48. So very good. Someone said, hey, Ms. Johnson, you're going to add 2 more to this difference. Good. And so if I added 2 more, that would be 13. And if I added that difference to here, then that would be 48. So here I'm just adding odd numbers, right? So that's my recursive function. I'm just going to add odd numbers. My explicit function is going to be a little bit different from that. Okay, and that's where we're going to pause and we're going to continue on our next time.